Okay, today we're going to continue our discussion about the special role of zero in factoring. Last video we talked a lot about the zero product property. And how if we have a product, let's just say x times y, and we have a product of zero when we multiply those two numbers, we know that either x or y must be equal to zero. And so as you kind of look at it in terms, this is a much more complicated problem than x times y, but essentially we can use this right away. And so there's going to be multiple ways to view this. We can break this down into further factors, or we can look at it right now and just say, well, these two things are factors. And since the product of these two factors is equal to zero, one factor or the other must be equal to zero also. So x squared plus 5x plus 4 equals 0, or x squared minus x minus 6 equals 0. And so when it describes find all solutions to the equation, I actually have to break this down just a little bit further. And what I know is I can factor the x squared plus 5x plus 4 even further, and I'll get x plus 4, x plus 1 equals 0, x plus 4 equals 0 since it's one of the factors, or x plus 1 equals 0 since it's one of the factors. And then I subtract 4 from both sides. So x equals negative 4, subtract 1, or x equals negative 1 would cause this whole entire equation to equal 0 since it's going to make the left-hand expression equal to 0. And we can do the same thing for the other side. So x minus 3, x plus 2. As you can see, that factoring and knowing how to factor is becoming really, really important for us. And so I have x minus 3 is equal to 0, or x plus 2 equal to 0. I add 3 to both sides. And so x is equal to positive 3, or x is equal to negative 2. And that big or kind of follows down. And what I end up with is what we call a solution set, because there's actually multiple answers that could potentially make this true. So negative 4, negative 2, negative 1, or 3 all will work. And these little curly brackets just mean solution set. Okay, you may want to pause the video at this moment just to kind of reflect on what's happened. These are a little bit more complicated. It's sort of combined multiple steps into one problem. And where we're going with this is eventually we're going to graph. And what you're going to notice on these graphs are when it says find the solutions and you see this 0 right here, really they're asking where does the y value equal 0? Well, that's an x-intercept or a 0. And so when you look at this, this is just a sketch, but you're going to find that you have a solution at x equals negative 1, and a solution at x equals negative 2, and a solution at x equals negative 4, and a solution at x equals positive 3. And you get a graph, and the graphs will coordinate with the degrees. Again, this is a sketch, so it comes all the way down and kind of looks like this. And so this is graphical representation of the polynomial on the left-hand side here, and the points where it equals 0, here, 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 and here, are the solutions. And so you can actually answer many of these graphically or algebraically, and that's something that we're going to further our discussion in. The next question kind of looks basic until you look at the fact that it has this exponent up there. What can we do with the exponent? So let's read this. Find the zeros of the following polynomial So if it's a 0, that means in place of h of x, I want to have the value 0, and it equals 2x minus 7 to the third power. And we know that when we see an exponent, we're really supposed to expand this, because an exponent means to multiply by itself the number of times of the exponent. But then with the zero product property, I know that each one of these factors can be set equal to 0. So I get 2x minus 7 equals 0, 2x minus 7 equals 0, 2x minus 7 equals 0. And I solve these, and I sort of notice that, well, they're basically the same thing. And to be honest, I don't really want to have to go through this each and every single time. Over and over and over again. And so we've coined this phrase multiplicity. And basically what it describes is the number of times that I will see a solution show up in my solution set. And so as you can see here, I ended up with 3 exactly the same answers. And so when you're looking at a graph, 7/2, it's kind of between 3/2 and 4/2, and your graph's going to just kind of, again, it's a sketch. Pause there for a second and keep going. Let's go a little. And so from the graph, we're not going to be able to tell exactly what's going on, so the equation becomes really important. So what we would say is solution x equals 7/2 has multiplicity of 3. And that to the reader indicates that you are solving the equation and you're getting the same answer 3 different times. And we can expand on that. Again, with the graph, it becomes really nice. But then they can give you questions like this. It says find 2 different polynomial functions that have a 0 at 2 with multiplicity of 5 and a 0 at -4 of multiplicity 3. So basically what they're telling me is that there's a 0 at 2 means that x equals 2 is a solution, and a 0 at -4 is x equals -4. But I really want these in 0 form, or kind of back to understanding where the factors came from. Well, I know that this came from x minus 2 equals 0. And this would give me the 0 at this factor, and x plus 4 equals 0 is the 0 associated with the factor x plus 4. And so again, you're kind of working them backwards. And so I know that factor must have been x minus 2. This factor must have been x plus 4. Now to address the multiplicity, my polynomial function would be f of x equals x minus 2. There's the factor, but it was supposed to happen 5 times. So I have x minus 2 to the 5th power times x plus 4 with multiplicity of 3. And so there's a basic polynomial function. Now from there it asks for 2 different versions of it. So to be honest, what you could do is just put a number out in front. So maybe it's the GCF, but I could put 2 or 3 or 7. And now all of a sudden this polynomial function is different than the original. Or we could do one last thing. We could add like x squared plus 1 out front, x minus 2 to the 5th power, x plus 4 to the 3rd power. And the reason why this works out is because this actually doesn't intersect the graph. So as you're looking at it, it won't hit where this occurs because these are in, we haven't really talked about these numbers, but they're imaginary solutions. And therefore they're not really zeros because you don't see them hit 0 at that point. Okay, a lot to contemplate here. Really focus on using the zero product property and this idea of multiplicity. Please summarize your learning, summarize vocabulary. Thank you for your time.